Welcome to this video on the projectiles lesson. Pardon me, this is lesson 19 of the Forces and Space scheme of work, and this is something that is definitely beyond what's covered in really any Key Stage 3 course, and in fact projectiles don't usually come in until Key Stage 5. And the problem students have with projectiles is that it requires them to think about motion in 2 dimensions, and that's why it follows on quite nicely from what we saw in the previous lesson, which was forces in 2 dimensions. Now we've got to think about how we could split motion into 2 dimensions. It's also a nice return to the example we saw right at the beginning of this scheme of work, the lesson on the kind of Aristotelian picture versus the Galileo Newtonian picture. And we're just going to look at that in a bit more detail, and students are going to get a chance to practice this and really apply some of these counterintuitive but incredibly powerful ideas. So what we're going to do first, well, in fact, this is the only thing I would model, I think, to students before giving them a chance to have a go themselves. But what I'm going to do is draw a basketballer on a basketball court. So let's draw my basketballer like this. A similar diagram to this earlier on in the unit in that lesson I just referred to. So let's draw a basketball hoop like this. And what we want to do is show firstly the trajectory of that basketball as it goes through the air. Oops. Now this can be quite hard to draw, so you might want to give, yeah, no, I've just missed. You might want to give this to students printed beforehand, something like that. It doesn't need to be perfectly accurate though. So something like this. Now what we want to do is something very similar to what we did in the lesson physical motion, because this, we will see, is almost identical to what's going on in that lesson, where we fired a bullet vertically upwards from a gun. And we're going to draw the velocity and think about the forces acting on the ball at different points in its journey. So let's think firstly about what's going on just after it leaves the basketballer's hand. Now, students might have this idea that because the basketballer kind of pushes it with their hand as they throw the ball, that somehow there's this lingering push force that keeps it going in the direction of motion. And again, this is, I guess it's a hangover of that Aristotelian worldview that we've been trying to rid them of throughout this scheme of work. And it's one to just address straight away. As soon as it leaves the basketballer's hand, it is no longer being pushed. We've got to get out of that forces or pushes and pulls thing, and really think about it strictly. The only force acting here is the weight acting downwards. And that's kind of counterintuitive, because we know that in this case, I'm going to do the velocity in red here, that the velocity is in the direction of motion, which, although my diagram is not the best, is kind of something like this. So that's the velocity there. So even though the velocity is in that direction, because the weight is acting downwards, accelerating downwards only. So now let's draw the basketball when it's kind of up here like this, nearly at the top. So now, hopefully students will see that the basketball is going something like this. That would be the velocity. And I don't usually do this, but I'm drawing the velocity arrows from the centre of the basketball as if it's a force. It's just worth emphasising to students that because we've not done it as a force arrow, this is not a force. Maybe that's misleading actually, because that reinforces the Aristotelian picture. But there is a reason for doing that, which we'll come back to in a sec. But again, the only force acting, and that's why I've done this in black, and I've got my block arrows, the only force acting here is the weight, and therefore it's still acting downwards. Now what's interesting here is what we can spot when we get to the highest point. So let's draw the basketball at its highest point. Now at this point, I've been actually drawing this without really kind of emphasizing it too much. Ideally, if you've drawn it properly, which I haven't quite managed to, but if you've drawn it properly, these velocity arrows will be tangents to this curve, so they will be exact tangents. And at the very top, the tangent to the curve looks something like this. So you get this perfectly horizontal arrow like that. And yet, if we draw the forces, well, it's just the same old weight pulling it down, and the acceleration, which I forgot to label there, is vertically downwards, as it has been throughout the journey. Now, what is quite interesting here is to notice the similarities with the bullet case, because if we split up our motion, and I might do this in blue here, this is perhaps going a little bit beyond year 8 physics, but I think it's a nice one for you as the teacher to be aware of anyway. If we split up the motion and we imagine that instead of being a kind of diagonal motion, we can split the motion into what we call vertical and horizontal components. That's the beauty of vectors. It doesn't really matter how you get there, as long as the overall arrow, whether it's a force, velocity, whatever, gets to the same point as multiple arrows joined together. So we can split these up and say, well, if that's the vertical velocity, VV, and that's the horizontal velocity, VH, we've got quite a large vertical velocity and a horizontal velocity like that. Now let's draw this over here, and this is where my arrows are not exactly to scale, but hopefully it illustrates the point. What we've got here, if we split this motion up, is that the vertical velocity has got a lot lower. The horizontal velocity, if I'd drawn it properly, would be approximately the same. And what we've got here is 0 vertical velocity, so VV equals 0, but then our horizontal velocity is just the same as the overall velocity. Now, this is the kind of slightly counterintuitive point that you want to emphasize to students, especially those students who may wish to go on and study A-level physics and do degrees and so on, is that what's happening here is because the resultant force is acting downwards, because you've got this downwards acceleration, what's happening to the vertical velocity is that it's decreasing in exactly the same way as the bullet from the gun did in a previous lesson. And I could actually refer back to that, and this is always a good idea with students to refer back to previous diagrams. This is exactly what we saw in this diagram, is that we started out with a high vertical velocity, then it got a bit lower, and at the top it got to 0. So what's happening in the vertical plane is exactly the same as what happened with the bullet from the gun. But what happens with the horizontal plane, and this is where we're really getting deep into these concepts that we've been looking at about Newton's first and second law and how forces affect motion, because there is no force acting horizontally, if I'd drawn it properly, which I haven't quite managed to do, but this horizontal velocity, this horizontal component of the velocity, stays exactly the same. So considered in the horizontal plane, it's almost as if this basketball is just traveling at a constant speed. And actually, the only thing that is going to affect the height of this is the vertical component of the velocity. So that's a really, really, really important idea for students to get their head around. Now, anyway, if we were to carry on, we could draw more of these. And actually, what you see in the examples that you're asking students to practice is really just identifying the direction of velocity and comparing that to the direction of the resultant force and the acceleration. But there is one hinge question which is asking about the horizontal velocity. That's probably for those students who are more confident with this stuff. But if they can think about this, then they're really thinking about these core concepts in a rich and kind of deep and quite profound way. And in that case, then they're definitely ready to go on and solve some really interesting problems when they get to Key Stage 4 and Key Stage 5. So what you'll see is some multiple choice hinge questions, and then there's some deliberate practice, which is drawing diagrams like this, admittedly diagrams without these blue arrows, although maybe you might want to ask your students to go into that in a bit more depth. Anyway, next lesson we'll look at circular motion, and then we are nearly done with this very exciting scheme of work.